So welcome to Everyday Mathematics. Today we now progress to the MIT Integration B qualifying exams 2011. And we're looking at problems 1, 2, 3, 4, and 5. Problem 1 is indefinite integral of x to the power 6 minus 1 over x to the power 4 plus x cubed minus x minus 1. Problem 2 is also an indefinite integral of 2 times the natural logarithm of x plus the square of 2 of natural logarithm of x. Problem 3 is also an indefinite integral of twice x over square root of 1 minus x to the power 4. Problem 4 is the indefinite integral of x squared plus 1 over x plus 1. And problem 5 is the indefinite integral of the cube of sine x plus square of sine x minus 2 sine x minus 2 over sine x plus this is sine x squared plus 2 sine x plus 1. So there is a square here, and let me just indicate it so that we can't forget it. There. So that's all for today, and please I hope you enjoy as we try and solve these problems. Yeah, for me, I do really enjoy these problems, and I hope you do enjoy them as well. So on to problem number 1, which is x to the power 6 minus 1 over x to the power 4 plus x cubed minus x minus 1. We can simplify the integrand, right? This part here. X to the power 6 minus 1 is the same as x to the power 3 minus 1 times x to the power 3 plus 1. Now, x to the power 4 plus x to the power 3 minus x minus 1 would mean that if I pull x to the power 3 out here, and I'm left with x plus 1 here, and I pull 1 out here, and I'm left with x plus 1, that means that we have now x minus 3, x cubed minus 1, x cubed plus 1. In the denominator, we have x cubed, because we have this common, so we have x cubed minus 1 and x plus 1. So that and that would cancel. And so we are left with something that is interesting. We have to divide x to the power 3 plus 1 by x plus 1. When we multiply by x squared, we have x squared, x cubed plus x squared, so that we have minus x squared plus 1 multiplied by x, we have minus x, we have minus x squared minus 1 minus x, and that becomes now x plus 1, and so we multiply again by positive 1, and we get x plus 1 here, and that becomes 0. So let me make that a little bit clear for us, so that we're just not lost. We're saying, okay, x to the power 3 plus 1 divided by x plus 1. We multiply by x squared, we get x cubed plus x squared. Subtract x squared plus 1, so that when we multiply by minus x, we have minus x squared minus x. So when we subtract this, we have x plus 1. So add 1, this x plus 1, and this is 0. So in other words, therefore, x cubed plus 1 over x plus 1 is the same as x squared minus x plus 1. And that means that now we just have to integrate x squared minus x plus 1 dx, which is equal to x cubed over 3 minus x squared over 2 plus x plus the integration constant, and that is what needs to be written. That's the answer that's required. So that is number one. It's just, playing around with the polynomials, not a very difficult problem. You just have to have this hard grasp of how to deal with polynomial fractions. Okay, so let's continue from here. So problem 2, which is the integral of twice natural logarithm of x, popularly written as ln x, plus natural logarithm of x squared. What I would do here, I would just say let u be equal to natural logarithm of x such that du dx is equal to 1 over x, and so du is equals x du is equal to dx, and since from here we can see that e to the power u du is dx. Why? Because from this expression x is the same as e to the power u. And so bringing this down now, the integral of twice natural logarithm of x plus is the same as twice natural logarithm of x, the same as u, and then natural logarithm of x the same as u, so this becomes squared, and then in place of dx, this here, it becomes eu du. So this is now integral 2u eu plus u squared eu du. Very interesting. So our integral that we've seen as this is the same as the derivative with respect to u of u squared, then times e to the power u plus u squared derivative with respect to u of eu. So the derivative of e to the power is the same as e to the power u. So when you have this integral is very simple. So this just tells us that we're differentiating the product of u squared and e to the power u, right? So when we're integrating the derivative of e squared times e to the power u, that's the same as u squared times e to the power u plus c, the integration constant. But we know what u is. U is u is the same as natural logarithm of x, and e to the power u is x. So that is the actual answer. So the square of natural logarithm of x multiplied by x is our answer, the final answer. You're not allowed to stop here. You cannot stop here. You cannot stop here. You need to actually express it back in terms of x. Problem 3, which is the indefinite integral of twice the fraction of x over square root of 1 minus x to the power 4. So this problem is the same as twice x over square root of 1 minus x squared 1 plus x squared. And if we say let u be equal to x squared, then that means that du dx is twice x, so du is the same as 2x dx, right? And that's very similar to what we have on top here. So that the problem now becomes du over square root of 1 minus u 1 plus u, right? So our problem is du square root of 1 minus u 1 plus u, which is the same as du square root of 1 minus u squared. We could just say let u be equal to sine theta, such that du d theta is equals cos theta, which means that you can substitute du with cosine theta d theta. And so our problem du over square root of 1 minus u squared is the same as cosine theta d theta over the square root of 1 minus sine squared theta, which is 1 minus sine squared theta is cosine squared theta, square root of cosine squared theta is cosine theta, so we have cosine theta over cosine theta, and that cancels. So now we have the integral of 1, which is theta, but since we said let u be equal to sine theta, then that means that theta is equal to arc sine of u. So this is arc sine of u. But since we also said let u be equal to x squared, that means that our integral 2x over 1 minus x to the power 4 x is the arc sine of x squared plus the integration constant. That is our answer. Okay, so that was a simple one. Problem number 4, which is the indefinite integral of x squared plus 1 over x plus 1. So a couple of things we can do here. The first thing is I could just separate. We have x squared over x plus 1 dx to integral 1 plus x plus 1, and obviously it's easy to integrate that, but let's try and create a fraction out of this. The easiest thing is to do a long division. Just say x squared x plus 1, so divide times x, x squared plus x, and that is negative x minus 1, become negative x minus 1, which is 1. So what this tells us, this is that x minus 1 plus 1 over x plus 1 dx, obviously plus our integral 1 plus 1 over plus x. So this here is us trying to resolve this part. So we can add this to this so that we now have integral of x minus 1 dx plus twice 1 over x plus 1 dx. So if our integral is the integral of x minus 1 dx plus twice the integral of 1 over x plus 1 dx, the integral of x is x squared over 2, integral of negative 1 is x, and then here is the integral of 1 over x plus 1 is natural logarithm of x plus 1 plus obviously the integration constant, and that is our answer. So the fifth integral is sine x cubed plus sine x squared minus 2 sine x minus 2 over sine x squared plus 2 sine x plus 1. So personally, we're not going to do substitution, but we're just saying that where x sine x is, let's just use a placeholder of capital X. Yeah. So we have a fraction like this to represent our integrand here, right? X cubed x squared minus 2 capital X minus 2 over x squared plus 2x plus 1, right? And so, I mean, a couple of things we could do here is to just do a long division, right? So we have x cubed plus x squared minus 2x minus 2, x squared plus 2x plus 1, such that when we multiply by x, we have x cubed plus 2x squared minus, no, plus x. So that here we have negative x squared. Here we have minus 3x minus 2. So multiply by 1, we are left with negative x squared minus 2x minus 1. And the difference there is minus x minus 1. This is the difference we get here. That means that x cubed plus x squared minus 2x minus 2 over x squared plus 2x plus 1 is the same as x minus 1 minus x minus 1 over x squared plus 2x plus 1. In other words, actually plus, sorry, minus there. So that we are left with x minus 1, and then we can put a minus there, x plus 1, x squared plus 2x plus 1. Which is x minus 1 minus x plus 1, and the denominator is, it's easy to see that this is x plus 1 squared, so that this and that cancel, right? And yeah, let's keep going. So this is equal to x minus 1 minus 1 over x plus 1. And since we said x is sine x, placeholder, x minus 1 minus 1 over sine x plus 1. One thing we could do is we could say, okay, to simplify whatever we see here, multiply the numerator with sine x minus 1, denominator sine x plus 1 times sine x minus 1, right? So this is sine x minus 1 minus sine x minus 1 over sine squared x minus 1, which is sine x minus 1 plus sine x minus 1 over 1 minus sine x, which is sine x minus 1 plus sine x minus 1, or divided by cosine squared x. Okay, so this is equals to sine x minus 1 minus sine x minus 1 over cosine squared x. So we have sine x minus 1 minus, as we can see here, we have not sec but sec x tan x minus sec squared x. So that our original integral two sine x minus 2 all over sine squared x plus 2 sine x plus 1 is equals to the integral of sine x minus 1 minus sec x tan x minus sec squared x dx. And we can see the integral there is cosine x, the integral of that is x, the integral of that is sec x, the integral of that is tan x, right? So essentially what we have is that the integral of sine cube x minus plus sine squared x minus 2 sine x minus 2 over sine squared x plus 2 sine x plus 1 is negative cosine of x minus x minus in bracket sec x minus tangent of x close bracket plus an integration constant, and that is the answer for the fifth problem. So yeah, thank you so much for hanging out with us. I hope you had some fun. Until next time, bye bye.